Okay, here we go. Today we're talking about worksheet 3.5, number 4. 3.5, number 4. Please stop talking. Thank you. All right, that goes away. Notes out. All right, you're going to be solving some very easy ones today, and then there's a few that have some tricks thrown in because they have basically some fractions in them that you kind of wouldn't expect. So, here we go. Let's try this one. 3 times 6 to the x equals 90. Well, my first thought is get the clump alone. You know what the clump is? 6 to the x. And so what are you going to do? Divide by 3. So it's 6 to the x equals 90 divided by 3 is 30. That's pretty easy, except it's got an x in the exponent. That's what is for. Logs. That's what a log is for. So we'll rewrite this with a log then. Go ahead. On your paper. Do you know how to write it as a log? Log base 6 of 30 equals x. Now, I didn't say it was going to work out nice. It just, that is the answer. Now, if they needed that to be a base 10 answer, do you know what to do? Because right now it's base 6. Just rewrite it so it's in base 10. Try it. I'll tell you if you did it right, because I think some people don't know. But I think most of you know. I do have a pinched nerve, but he said basically just keep taking Advil, and it takes a while for nerves, but it'll be fine. So, okay, here we go. Log 30 over log 6. And actually, yes, it was squats that did it to me. It's true. No, not enough to be proud of, so I'm not going to keep going. Okay. This next kind, what we need to do is review the U substitution thing. So do you remember if we get a problem down to something like this, 2x plus 1 and x minus 3, that you're really close to done? What are the two answers for this one? Don't say them, write them down on your paper. Figure out what the two answers are. Okay. You should have said 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. And you should have said x minus 3 equals 0, x, and add 3 both sides equals 3. There's your two answers. Okay, that should be like easy right now. Okay, we've done those since the beginning of the year. So why is this any different? Because in the beginning of this problem, it would have been written in such a way that when you rewrote the thing, you would have come out with this equation. And only after you had done a U substitution. So like let x equal log of x. Meaning that there was a log of x in the problem, and when you pulled it out, you put in normal x's like this. And now, if you're to this point at the end of the problem, you don't get to quit then. You got to substitute the log back in. Would you try putting a log back in for both of your x's? You put in log x and then solve it. Log x equals negative 1/2, and log x equals 3. And now you got to do another little math problem to finish it, because this one has base 10, and so does this. Oops. And now you go 10 to the power of negative 1/2 equals x. Do you get how I had to do one last step there? Okay, the reason that I would have had to do that is if the original problem had log x's in it, and I pulled them out and put in just plain x's so that I could factor it nicely. All right, I'm going to give you a problem like that again. Let me finish this one off. 10 to the third equals x is the other answer. So my two answers were 10 to the third and 10 to the negative 1/2. By the way, is this a negative number? No. 10 to the negative a half means the square root of 10, except you flip it. The negative up there in the exponent means flip it. So 1 over the square root of 10. All right, so let's have one that actually you have to actually put together. This would be log x minus 4 plus log x plus 2 is equal to, let me think about this, log one. All right, here's how you do this one. Do you get that those two can go together? So they make log of x minus 4 times x plus 2. And on the other side, I have log 1. Well, what's log 1 equal to? You won the argument. Remember that one? It's equal to 0. Okay? But you could take two different approaches on this. Do you get that you have a log base 10 here and you have a log base 10 here? Couldn't you just cancel the log base 10s on both sides? Yes. But let me show you why you could have also done it the other way. This would have worked. Cancel, cancel. And then I have x minus 4 times x plus 2 is equal to 1. But if I didn't do it that way, I'd still get a 1 over there. Here's why. Because, do you get how this is supposed to equal 0? When you won the argument, you're supposed to get 0? If there was a 0 there, then I'd have to do a rewrite. Do you get how if I make this into a 0, I got to rewrite this because I can't just cancel the logs on both sides because there isn't logs on both sides anymore. And then I'd say 10 to the 0, which by the way equals what? What is 10 to the 0? 1 equals all this. So either way, it comes out to x minus 4 and x plus 2 equals 1. Now, the painful part is it's not set equal to 0. Because if it was equal to 0, I'd just have two answers. X equals 4 and x equals negative 2. That would be no big deal. But this one's set equal to 1. So what you have to do is multiply it all out, bring the 1 over to the other side, and then see if it will factor once you set it equal to 0. Yes? X plus 2 equals 1. No, you can't. Now, you can't set this equal to 1 and this equal to 1. That's the special property of 0 being over there. Because if you set this equal to 1, this is going to probably be something else besides 1. In other words, like I could make x negative 1, but then when I put a negative 1 right here, I'm going to get negative 5 times the 1, which would be negative 5. So bottom line is, no, that doesn't work. You have to set it equal to 0. So how do I get it equal to 0? X squared first, outside, inside is minus 2x, last is minus 8 is equal to 1. Then I bring the 1 over to the other side by subtracting 1. X squared minus 2x minus 9 equals 0. And what happens if I've got a quadratic this far and it won't factor? If it won't factor, quadratic. X equals negative b, which is negative negative 2, which is 2, plus or minus square root of b squared, which is what? 4, minus 4 or 8c all over 2a, and 2 times a is 2. And the a part was 1, and the c part is negative 9, and so this makes x equals 2 plus or minus, let me think, 4 plus 36 would be 40, square root of 40 all over 2. And could you leave it that way? No, because the square root of 40 could simplify. Root 4 and root 10, which is 2 root 10. So then it's 2 plus or minus 2 root 10 all over 2. Look at that. There's 2's running all over the place. Cancel, cancel, cancel. And they don't disappear when they cancel. They make 1s. X equals 1 plus or minus root 10. And can I simplify it any more than that? I don't think so. So there's 2 answers. 1 plus root 10 and 1 minus root 10. Now, last thought. How do I know if I've done it right? Maybe you should check it. Do you get that the square root of 10 has to be something like bigger than 3? Because 3 squared would make 9, so it's like 3 point something. If I do 1 minus like 3 point something, do you get that's going to come out negative? If I look at my original problem, can I have a negative number right there? Nope. Because if I have a negative number like negative anything, like negative 2 or whatever, it's going to come out to an argument that's negative. Log of a negative number is not possible. So the negative one gets thrown out. So of these two, it's not plus or minus anymore. It's just plus. So the final answer would be, oops, just plus. 1 plus root 10. Whew, that was a hard one. Almost all of it was algebra, though. Like, only at the beginning do we have a little bit of log stuff to do. We had to compress it. Condense, I think, is the word we usually use. And we had to do a rewrite, or we could have known that that was the same base, and so the logs could cancel, and either way it equals 1. Once we had it set equal to 1, though, it was all algebra from there all the way down. Just a lot of algebra. And then also checking your answers. Watch out for that. We like to throw in ones that are extraneous. So don't just assume if there's 2 answers that they both work. It's probably pretty likely one of them doesn't. And the reason it won't work is if you stick it in and it turns out to make the base or the argument, one of these 2 spots, if it makes them negative, then that's a bad thing. Okay, that's enough review of old stuff for today. I'm going to do a few problems with you off this worksheet, so I'm going to pause for a second while I hand it out. Again. Okay, number 1 we did in class earlier, so if you took any notes or if you just have a decent memory, that should be easy for you. Number 2, I'd also want to get the clump alone, but you better remember what 12 to the negative 1 power is. What is 12 to the negative 1? It's 1/12. And then when you're dividing by 3, when you have 1/12 divided by 3, I personally would want to take 1/12 times by 1/3. Same deal, flip and multiply fractions. You've got to be able to handle that. So again, I'll help you with number 2. I can tell some people are kind of lost because they're not sure exactly what I'm doing because I'm saying it verbally and you're more of a visual learner. 3 times 6 to the x equals 1/12. Then, instead of times by 3, I'm going to multiply by divide by 3, I'm going to multiply by 1/3. Because that'll still work to cancel this, and that works way nicer right there. 6 to the x equals 1 over 12 times 3 is 36. Now, you have 2 choices. You can either make both bases the same right here and then make their exponents equal, or you can do a rewrite and put it into a log. I personally am using the log. Log base 6 of 1 over 36 is equal to x. Because see, I got x alone now. Yay. But the problem is, you can simplify this. You get that 36 is really 6 to the something. Once you figure out what it is, you'll have the answer. Okay, so let's move on to, let me help you with number 8. Problem number 8 says log base 1/5 of 25 is equal to x. Now, it's fairly common for people to want to take this and change it to a 25 to a power, and you never do that. Never touch the base. You can take this 25 and rewrite it as a 1/5 to a power, and then you'll have the answer if you do. What is 25? 1/5 to the what power? 1/5 to the, well, you got to square it to make it 25, right? There's 2 parts to negative 2. One is squaring. 1/5 squared is 1 over 25. And then there's the flipping part, and that worked. Good job. So we just rewrote 25 as 1/5 to the negative second power. So we can put that wherever there is a 25. Well, there's a 25 right there. So you can do that, and then you'll have the answer because it's the exponent. All right. Now there's a lot of different kinds on here. There are quadratics on here. Don't think it's that hard. Okay. I will remind you how to start number 4. Number 4 is one of those U substitutions. Okay. Need you up here. I only turned because you were talking. Number 4, e to the 2x equals 3e to the x. All right. And now I'm going to do a U substitution because this is complicated. But if I pull out the e to the x out of both of them, I can put a u in there, and it'll make it way easier. U squared equals 3u. That should tell you, oh, this is one of those quadratics. See, I've got something squared. Anytime you have something squared, you got to follow the quadratic pattern, which is try to get it to factor after you set it equal to 0. And if it won't factor, you've got to use quadratic formula. But almost always, we're going to make them factor. This one factors. So u squared minus 3u equals 0. And once you get that thing factored down, u times something. And then when you got your answer, remember, you're not done. You'll have 2 answers, u equals 0 and u equals something else. I don't know what the other one is because you have to figure it out. Then I can't finish, though, because I let u equal e to the x. So then at the end, I have to take my u's and change them into e to the x's and then solve for x. So you'll have to rewrite it as a log. So one step at a time. At the beginning of this problem, I knew right away, because I saw a squared. If you ever see a squared, it's setting you up for one of those kind of quadratic problems. And you probably want to do a u substitution to be able to make that work. I pulled out the thing I circled in red here. I pulled out the e to the x, and I put in a u. Are you allowed to what? I haven't got a 0 in a log yet, but if you are you talking about having a base of 0? An argument of 0? Okay, if the argument is 0, that's a problem. You're not allowed to have in any, let's say it was A, B, and C. C can be anything in the world, but A and B have to be positive numbers and they can't be 0. So if you've ever got a 0 here or here, you can't have that. That's undefined. C can be anything you want. All right, back to this. I let u be e to the x. I put in a u here. I factored it, and I'm surprised how many people can't do this, but it comes out to u and u minus 3. And then that means the 2 answers are this equals 0 and this equals 0. And how do I set u minus 3 equal to 0? Just like this. They add 3 to both sides, u equals 3. Then I have my 2 answers, u equals 0 and u equals 3. Why can't I stop right there? Because I made the problem easier at the beginning, I have to now make the problem harder because I pulled out the e to the x before. Now I got to put the e to the x back in. So u is really e to the x, and this u is really e to the x. And then you have to solve those 2 at the end to finish the job.
So that equals 0.
I'm not going to finish it. You have to finish it. I got it that far. Okay. All right. So moving on to number 16. Everybody turn it to number 16. Log base x of 16, and then that's squared. That gives me a hint that this might be a problem that's a quadratic. Minus 4 equals 3 log x of 16. If you get the concept of a u substitution, you get that I'm looking for things that are quadratics like this. And if I can make anything equal to u to just make my life simpler, I can. I can pick even that and make that my u substitution. I can pick anything I want and say I'm going to let u equal that. So now it's u squared minus 4 equals 3u. And from there, you have to be able to handle quadratics. I can't go back and reteach you quadratics again. You have to be able to solve that puppy. Get the answer. Let's say the answer comes out to u equals 2 and u equals 5. Then you have to do a u substitution back in and take this, and if you're letting u equal log base x of 16, then down here where you have a u, you get your answer and it comes out with a u equals, then you put this back in down there and solve it for x. And that's just a baby one at the end. It's really easy. Log base x of 16 equals 2, and you can rewrite that and solve that. It'd be a piece of cake. All right, so moral of the story, you need to find out what this factors to and get your answers to it. When you're done, you won't be done because you'll have to plug this back in for u twice. You're going to get 2 answers, so you have to plug it in and get 2 new answers. Okay, that's all the review I want to do with you. That was mostly a review of u substitutions. There's really nothing new on this worksheet. It's just combining a lot of things. If you are stuck, you can come up and ask for help.